Okay, let's do it a bit quick today. Yeah, busy as always. But we are still moving on to chapter 14, and we have more chapters to go. But let's finish this. Right, so cargo and crate. So we are talking about like packaging, releasing category, I guess. We are just using the most basic feature right now to build, run, and test our code, but we can do a lot more. This chapter we will discuss some of its other more advanced feature to show you how to do the following, including customizing your build through the release profiles, publish libraries on crate.io. So that's like PyPI for Python. So that's like where you can publish your thing. Organize large projects with Workspace, install binaries from Crate, and extend cargo using custom commands. Okay, there's even more, but I think as a learner, we would kind of stop there, I guess. Yeah, see documentation if any doubt, and customize builds and release profile. So I guess we have the TOML file. Everybody got a TOML file, cargo.toml. Right, so release profiles are predefined and customizable profile. So there will be a dev profile that cargo uses when you run cargo build, and the release profile that when it will be used when you do cargo build release. The dev profile is defined with good defaults for development, and the release profile is optimized for release. So so it will be showed when we build something, finished dev and optimized, debug info targets. If we do release, it will be released optimized targets. So we have two profiles. So when we write like cargo.toml, we can define them differently. Profile.star, so it's like dev and release is here. So optimal level 0 for dev and then 3 for release. These are the default values. Up level settings control the number of optimization Rust will apply to your code with a range of 0 to 3. So 3 is the max, 0 is nothing, I guess. Applying more optimization extends compiling time. So if you're in development and compiling your code often, you want few optimizations to compile faster, so the development cycle is faster. Even if the result code runs slower, it doesn't matter if the result code runs slower. We're just like testing things. The default object level for dev is default 0, which is the lowest. When you're ready to release your code, it's best to spend more time compiling because it's the final thing you're shipping it. So you better make it nice and spend more time on it. So it's the best, which is fully optimized. So only compile in release mode once, ideally, unless you release another patch or whatever. But you will run the compiled program many times because people are using it. So release mode tends longer compile time. So it'll be so the trade-off is like we'll rather spend more time compiling because it's supposed to be used by many people, but it will run very fast. So that's the max level 3. You can override the default value in the cargo.toml. For example, we want to optimize the level 1 during development. You can do that as well. So that's one thing. And then we will have another, publishing a crate to crate.io. So I don't think we are releasing anything right now. Wow. Do I want to do that because If they have a sandbox that I can play with, maybe I will, but otherwise I won't. I will just read it, and when we in the future have a time to do anything, then maybe, yeah. We use package from crate.io as dependencies of our project, but you can also share your code with other people by publishing your own package. The crate registry at crate.io distribute the source code of your package, so it's primary host code that is so your source code will be hosted as well. Interesting. Well, I guess nowadays people still, will upload a project to GitHub, but I don't know how crate.io. Maybe let's have a look there. It's very interesting. Install cargo, we already have getting started, and we have lots of downloads and a lot of crates in stock. The new ones, the most downloaded ones, the just updated ones, most recent download, popular keywords, popular categories. There are lots of crates. Can we just maybe check the most downloaded ones? Parser for Rust source code. The parsing library for parsing a stream of Rust tokens into a syntax tree. Ooh, okay. I guess this is used by a lot of other libraries. That's why it's there. I don't know enough to judge, but yeah, they also have the link to GitHub. There will be who is the owner, probably the maintainer himself or herself, but this case I bet is himself. So install cargo at. So this is how you install it. This is the latest version. Is MIT license. MIT. Oh, what? Why there's two? Okay, maybe there's two. Yeah, MIT or Apache. Both are penetrative ones, so it's fine. Like you can just use it without too much restrictions. 3 days ago, there are a lot of versions, different things, 2 point something. This one is deleted for some reason. Ooh, okay. Maybe some security issues. I don't know. I don't know enough to judge. Wow, 109 and then jump to 2. Congratulations. Dependencies. There are good dependencies. They have dependencies. So there are 2 sets of dependencies. These are the development ones. These are the one that you needed. So it will get shipped together when you install it, I think. Dependents, lots of them. No, not, well, a lot. 9 pages. So yeah, this is a very popular library. It's most downloaded. Try on Rust Playground as well. So this is probably the README about how to use it. I'm not going to dive into detail because we may get more chance in the future, but not now. Downloads. Interesting, there's like a trend. These are the weekends, right? So nobody's working, maybe. Yeah, probably these are the weekends. You want to go out and touch grass in the weekend, you know. You don't want to like stay and like indoor others. So this is the latest. So this is, I think this is when it's got released. I think no, this is the latest, this one. Okay. Right, I still can't find the source code of it. Documentation, repository, there's like docs.rs. Interesting. Let's see. Features that make your published package easy to use. Easy to find and use. We will talk about some of these features. Useful documentation comments. So we would use // how to comment using 2 slashes for a particular kind of command for documentation. So it's like docstring in Python, but this we call documentation comments. So this will be like everything here will be generated in the HTML documentation. So use 3 slashes instead of 2 and support markdown notations for formatting the text. Place documentation commands just before the item they are documenting. I really like markdown. Like Python still mainly RST just because of historical reason. But nowadays Markdown seems more popular. Like GitHub is using Markdown, and a lot of things are using Markdown. So yeah. Documentation comments for add one function in the crate name mycrate. Example. So this is example, and then this. So, but this belongs to add one. So you just add that before the thing. Description of what add one function does. Start a section with the heading examples, and then provide code that demonstrate how to use the add one function. We can generate HTML documentation from the documentation comment by running cargo doc. This will run the RustDoc tool distributed with Rust. So it comes with this. For convenience, using cargo doc --open will build the HTML for your current crates documentation, so you can preview it, as well as the documentation for all your crates dependencies as well. I think we've seen it once, somehow, a lot of videos ago. Open the result in a web browser, navigate the add one function. You will see how the text in function command is rendered. So this is how it looks like. Yeah, it's quite good. You don't have to, so it's just like automatically generate the HTML documentation. You don't have to use extra tool for that. Commonly used sections, so we have example like this. There are some other sections that may also be used commonly. For example, panics. Of course, you will tell people when this function would panic. Call off the function don't want the program to panic should make sure they don't call the function in these situations. Basically, like, yeah, it's kind of important to see like how to use it and how to use it properly so you don't get the panic. If the function so instead of panic, if the function will return a result also when it will give an error, describing the kind of error and also what kind that might occur and what conditions may cause those errors to return can be helpful as well. Safety, if the function is unsafe to call. We'll talk about that more in chapter 90. It sounds weird, like the function is unsafe. It's like, but why do we make it unsafe? There should be a session explaining why the function is unsafe and covering the invariants that the function expect callers to uphold. So, yep, this is very important, I guess, but we'll talk about it in chapter 19. So sometimes you don't need all the sections because, for example, mine is very saved and I don't have to, I don't know. And also, yeah, if it's just panic, you don't need error as well. But it's a good checklist to remind you that what is good to be talked about. Okay, so documentation comment as test. Oh, doc test. So adding example code block in your documentation comment can help demonstrate how to use your library, and also doing so additional bonus because you can do doc tests. Running cargo test will test the code examples in your documentation as test. Nothing is better than documentation with examples, but nothing is worse than examples that don't work because the code has changed. So this is good. That also makes sure your example and documentations are in sync with your code. This is super important, and this is a really good idea. I think in Python you can also do doc tests, but you may have to use extra tools to do it. If we run cargo test with the documentation for the add one function, it will result like this. Doc test mycrate, running one test, and then it's one passed. So example, and then here these are the code. Does it check whether it's like in the code block, or does it check also is under example as well? Interesting. Yeah, now I want to test it out. Maybe I should test it out. So there's the add one function. So I think if I generate a new cargo new test doc. Yeah. Let's see. So if we go to test doc, nope, not this. Main. Hello world. Oh, but we need the library ones. How to generate the library ones? Good question. I forgot. Okay, let's remove this because we don't need it. Let me close this first. Okay, so how to generate the thing is lib, something like that. Usage? Huh, can't remember. So cargo new dash help. Yeah, lib. Use the library template. So if I do cargo new, maybe dash lib. Yeah. This time I would have a lib. Yay! So I have the add function. I can change it to add one. Or maybe I can add this as well. Oh. So now if I run the test, oh, failed. Oh, okay. Answer equals to migrate. This is not migrate. This is test dot. Okay. So now, yeah, we have one dot test, and then it's okay, and all this. So it found this. So what if I change this to example, not examples? This is demo. Let's call it demo. Does it also run? It also runs. So I guess it's that code block that matters. If I don't do this, I think, yeah, there will be no test. But here I have one test, so it doesn't matter like what is it called example or not, but it will still run the test if you have some code here. So cool. And then right, let's go back to where we were. We were here, we run this, which is fine. Containing items. What does it mean? The style of a document. So /s exclamation mark adds documentation to the item that contains the comment rather than to the items following the comment. We typically use the doc comments inside the crate root file or inside the module. Document the crate or the module as a whole. So this is like the Python docstring that's like all the way at the top of the module, and then it's basically describing the whole module itself rather than containing the comment rather than the item following the comments. Describe the purpose of microcrate containing the L1 function with a documentation comment that start with /s exclamation mark to the beginning. So it's like this. So you can add this will, where am I? Okay. Yeah, if you add this, then now, then we'll have my crate. How to run that again? Cargo doc open. So now we will have, I don't know why it's like, is it by default? Oh, okay, system preference. You have different themes. Oh, cool. Like that. I like that. Oh, not like that. Too bright. Prefer dark theme. Oh, this is cool. Prefer light theme. I don't know. I don't want to change to light theme right now. Cool. Okay. At one, I have now at one. I have also my crate. Now have a description, and then now I have the example here as well. Cool. So very nice, very nice. yeah, kind of like that, but I have a different theme. Exploring exploring a convenient public API with pub use. So, structure of your public API is a major consideration when publishing a crate. People who use your crate are less familiar with the structure than you are and may have difficulty finding the pieces they want to use. If your crate has a large module hierarchy. In chapter 7, we discover we can bring the public API using the pub keyword and bring the item to scope with use. So we can make something public, and then you can also use to bring it to the top. However, the structure that makes sense to you while you are developing a crate may not be very convenient for your user. You may want to organize your structure in a hierarchy containing multiple levels, but then people who want to use a type you have to find deep in the hierarchy may have trouble finding out. For example, use my crate blah 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 blah. There's a lot rather than using use my crate useful type. So yeah, you may want to bring useful type to the top level. Good news is that if the structure isn't convenient for others to use from another library, you don't have to rearrange your internal organization. Instead, you can re-exploit items to make a public structure that is different from a private structure using pub use. Re-exporting makes a public item in one location and make it public in another location. For example, you have a library called Art, which is for modern artistic concepts, and then within the library there's two modules, kinds, and two enums named primary color and secondary color, and a util module containing a function named mix, like this. Right. So this is the current documentation. We have art, and then we have module, kinds, and util. Note that the primary color and secondary color type aren't listed on the first page, nor is the mix function. You have to click into it to see them. Another crate that depends on this library would need to use the use statement that bring the item from Arch into scope, specifying the module structure that they're currently defined. So this is how it get used if you want to use primary color and mix. So use Arch kind, primary color, Arch util mix, like this. All of the code in the one in here, which uses the Arch class, has to figure it out. Primary is inside the kind module and mix is in the util module, and the module structure of the Arch crate is more relevant to developer working on the Arch crate than those using it. Because if you're developing, you probably want to organize things this way, but for people using it, they may not care. Yeah, the internal structure doesn't contain any useful information for someone trying to understand how to use the Arch crate, but rather cause confusion because developers who use it have to figure it out where to look. To remove the internal organization from the public API, we can modify the Arch crate code in. You can modify your code, but you probably don't want to do that because that makes sense to you when you are developing it. Add pub use statements to export the item, but what you can do is to use the pub use statement like this to export it. So for example, in your libs.rs, this is top level, so you can use pub use to bring it on the top. So now it will so these are re-export, so you will see them. Now list and link the re-export to the front page. Arch crate user can still see and use the internal structure, or they can use a more convenient structure just like this, because now they're at top level, even though this one will tell you where they actually are, but now you can just call it like this because we have used pub use. In case where there are many nested module re-exploring types on the top level with pub use can make a significant difference in the experience of people using the crate. Other common use of pub use is to re-export definitions of a dependencies in the current crate to make the crate definition part of your crate's public API. Create a useful public API structure is more of an art than science. You can iterate to find the API that works best for your user. So it's a tool that you can use, but we can't tell you how to use it because it's an art and you have to discover it yourself. So set up a Crate.io account. Yeah, this is the territory that I don't think I'm ready for. I don't want to mess with the public goods, which is the Crate.io. So I won't do it, and I don't want to do it on screen because I will probably have to pick a password. And you will see and probably guess from my typing that what my password is, because there are smart people out there. So no, I won't do it right now. Before you can publish any crates, you need to create an account on Crate.io for sure, and get an API token. To do so, visit the homepage and then log in with, you can log in with your GitHub account. I guess I don't have to type anything, but yeah, I still don't want to. It's too risky. I mean, lost my token because of that. Lost it to you. The GitHub account is currently a requirement, but the site may support other ways in the future. So right now, I guess because of that, most of the Rust projects that have published on Crate.io will have a GitHub account. But yeah, in the future, you may be able to use others, but so far just GitHub. Once you log in, visit your account settings and retrieve your API key. Then run Cargo login. So this is how you can log into Cargo. You need to use your API key, so I'm not going to do it on screen. This command will inform Cargo of your API token and store it locally. So it will store it in your credentials. Note that this token is a secret. Don't share it with anybody else. And that means you. If you don't share it with anybody for any reason, you should revoke it and generate a new token. Yeah. Always be careful with your API token, people. Don't put it on GitHub. don't commit it on GitHub. We have all been there. Yeah, be careful. Adding metadata to a new crate. Let's say you have a crate you want to publish. Before publishing, you would need to add some metadata in the package section. For example, the name of the package is very important. So the names are first come, first serve. Yeah. So once a crate name is taken, no one else can publish a crate with that name. Before attempting to publish a crate, search for the name first. If the name has been used, you will need to find another name and edit the name field. Even if you have chosen a unique name, when you want Cargo publish to publish the crate at this point, you will get a warning and then an error. Fail to publish. Error because you're missing some crucial information. You can't just have just the name. A description and a license are required so people will know what your crate does and under what terms they can use it. So license very important. Cargo.tom will add a description that is just a sentence or two. That's the description for your crate. You appear with your crate in search result. License, you need to give a license identifier value. Look it up. So Linux Foundation have the package in the, so this is mostly like, MIT or like Apache something, or Apache 2.0, or there's like others as well. Like, yeah, you can look it up online. Here's a license that doesn't appear. We need to place the text of that license in a file. Include the file in your project and then use license file to specify the name of the file that are using the license key. So you need the license file, but I would never suggest someone do that. Just use one of these licenses from this, or go to OSI, Open Source Institute. They have a list of approved license for open source projects. You will find something there for sure. Use something that's popular, that everybody understands. Is better than defining your own, because we are not legal experts, and it costs a lot of time and money to write all these legal things, so don't do it yourself. It's not fun. Just use something like MIT or Apache. Yeah. Guidance on which license appropriate for projects beyond the scope of this book. Yeah, it's very complicated, but my suggestion is always choose something that the OSI approve. Just read different ones and see which one suits you. Many people in the Rust community license their project in the same way as Rust. So Rust is MIT or Apache. Okay, dual license. I don't think you have to be dual license. Sometimes like just MIT is okay, but again, like read about the differences. I'm trying to write a blog post about the different license, but that's going to be very beginner friendly, so it's not going to dive too deep either. If you really want to, you can dive down, but for most people, I think, yeah, MIT would work. But MIT is like one of the most free ones, so when people use it, they can use it quite freely. That may not be what you want, then you have to look for another license. This practice demonstrates that you can only specify multiple license identifiers separate by OR to have multiple license. So if you have multiple license, separate them by OR with a unique name, the version, your description, and a license. So you need a version as well. Start with Open 1.0 most of the time, I think. Yeah, so this is what the minimal kind of setup looks like. Publishing to Crate.io. Now you have create an account, save your API token, choose a name of your crate, and add all those like metadatas. You're ready to publish. Publish a crate uploads a specific version to Crate.io for others to use. Be careful because a publish is permanent. That's why again, like I don't want to mess with it. The version can never be overwritten, and the code cannot be deleted. One major goal of Crate.io is act as a permanent archive of code. So if you, for example, publish something that has a bug in it, probably the practice is not to delete it and rewrite it. Is to just to publish a patch, which is like the next patch version. So you only go up. You will never go and delete the previous ones. I think if you delete, it's a very, very special case that if it got deleted. So one of the major goals of Crate.io, it's a permanent archive. So once it's uploaded, it's there. All the projects, depending on the Crate from Crate, will continue to work. Yeah, because if imagine you are using a particular version of some other libraries, and the owner just decided to delete it, and then everything will get broken. In the future, you can't download it and use it. It's very annoying. Even though if it's like security problem, usually it's just like publish a new patch as quick as possible, and people are using it to like upgrade it as soon as possible. So that would be the best solution. Allowing versions deletion would make future goal fulfilling that goal impossible. However, there's no limit the number of Crate version you can publish. So you can publish a lot of different versions, but when Kaggle publish a command, then it will get published. Congratulations, and I would do that in another time. Publishing a new version of I feel like it's very stressful. Like, I mean, you can always publish a patch one if there's like something wrong with it. Like, yeah, if you have been told this operation cannot be undone, there's like always a very scary thing to do. So yeah, I do feel the stress. Yeah, that's why release manager is a tough job. Okay, publishing a new version of an existing crate. When you have made changes to your crate and are ready to release a new version, you change the version value. Yeah, so we're using semantic versioning rules. So I believe it's patch, minor, and then major, from right to left. So an appropriate next version number is based on the kind of changes you've made. The run Kaggle publish to upload the new versions. Deprecating versions from Crate.io with Kaggle Yank. Although you can't remove the previous versions, you can prevent any future project from adding them as a new dependencies. This is useful when a Crate version is broken for one reason or another. In such situation, Kaggle support yanking a Crate version. So this is kind of the closest thing you can have with deletion. Yanking a version prevents new project from depending on that version, while allowing all existing project that depends on it continue. Essentially, a yank means that all project with Kaggle.log will not break, and any future Kaggle.log file generator will not use it. To yank a version of a crate in the dictionary, in the directory of the crate that you have previously published, run Kaggle yank. and specify which version you want to yank. For example, if you have published a crate name guessing game version 1.0.1 and you want to yank it, then you just go to the directory for your guessing game, and then go to cargo yank and then specify the version you want to yank. Adding the undo to the command, you can also undo a yank. So this is safer. It's not like delete permanently. And allow project to start depending on the version again. So yank is not like deleting, so it just prevents future version to not use it. So it can be easily undo. It can avoid. Example, delete accidentally upon upload the secret. Ooh, if that happens, you must reset those secrets immediately. Yeah. So like, for example, if you, I think it's the same as GitHub. It's very difficult to remove the so that's why just you reset the secrets, which means that, for example, if you accidentally leak a API token, you can always revoke that one, so that one doesn't work anymore, and generate a new one. So unfortunately, this is how we solve problems. Yep. So this is publishing Cargo workspaces. In chapter 12, we built a package that includes a binary crate and a library crate. As your project develops, you may find that the library crate continue to get bigger, and you want to split your package further into multiple library crate. Cargo offers a feature called Workspace that can help manage multiple related packages that are developed in tandem. So, Workspace is basically a collection of different libraries, library crate. A set of packages that share the same cargo.log and output directory. Let's make a project using a workspace. We will use trivial code so that we can concatenate on the structure of the workspace. Multiple ways to structure a workspace, so we'll just show one common way. We have a workspace containing a binary and two libraries. The binary, which will provide the main functionality, will depend on the two libraries. One library will provide a add1 function, and the other one will provide an add2 function. Very simple. This three crates will be part of the same workspace. We'll start by creating a new directory for the workspace. In the add directory, we create the cargo.toml file that will configure the entire workspace. So yeah, this is the add directory, and then this okay, we just create a directory and go there. Then we create a cargo.toml file. This file won't have a package section. Instead, we'll start with a workspace section that will allow us to add members to the workspace by specifying the paths to the package with our binary crate. For example, that path is adder. So so it just tell you what is included inside. So now we have adder. We'll just create new adder. So it's a binary application. So we just run cargo new, and then after that, so we can build a workspace by running cargo build. And the file in your add directory should look like this. So you have a toml, you have a log, you have the adder, which inside it has its own cargo toml and source and main. Target is actually top level. So yeah, a compiled and artifact will be placed into. So instead of having separate ones, you will be top level. The adder package doesn't have its own target directory. It will one cargo build from inside. Even if you run it inside the adder, it will not be there. Compiled artifact should still end up with add target, so it will still go into top level rather than add adder target. Cargo structure target directory in the workspace because the crate in the workspace are managed to depend on each other. If each crate has its own target, each crate would have to recompile each of the other crate. Yeah, imagine if you because they're all working together. So if you update one, you need to update the other one, and it's a nightmare if you have to do it separately. yeah. Sharing one target directory, the create can avoid unnecessary rebuilding. Creating the second package. So now I add. So now we add one, and then we can also cargo new create one. This time is the library, and then now we have this structure instead, and then we add one. Then now in the adder, the binary ones, because it's using add one, so you have to, in the dependencies, you have to add one is from the path add one. So dot dot slash is basically just mean here. Kaggle doesn't assume the create in the workspace will depend on each other, so we have to explicitly tell them like where can I find this add one. Use the add one function. So now we can use it. Use add one. And then cargo build again, it will be into the top level target. To run the binary crate from the add library. Yeah, so depending on the external package in a workspace. So you can, of course, also depending on external packages, you just have to do what we did before. Ren equals to this versions. Yeah, we only have one cargo log file at the top level. So this one is, okay. All create using the same version of dependent. If we add a ran package to adder and add one, cargo will resolve. So there's also a resolver to find the version that works for both of them. So both of those to one version of ran and record that in one cargo log, which is the top level one. Make other crates in the workspace use the same dependencies. Always be compatible with each other. That makes sense. Right. So yeah, you can define different dependencies in each one of them, but at the end there will be a resolver, and you will get one will be chosen at the cargo.log. If they can't they won't be compatible with each other, then we have a problem. then your crate won't probably work together with each other because they depend on different versions of things and they are not compatible. So you have to fix that dependencies issues anyway. We can now use rand now, and this is how we do it. Sorry, I'm not doing it. I just want to quickly go through all of them. We have done this kind of things to many times, so it's just like running a lot of commands to build them and understanding what's going on. So I'll just read through them. So now, one cargo build in add directory. Get one warning because we aren't referring to range that we brought into scope. What's going on? So add one is using it here when because it hasn't been used in the code, is it? Or you just add, okay, just add use rand in the add one lib. Yeah, yeah, because you use it but you haven't really used it, that's why it's not happy. I think it's fine for now. Just demonstration. Top level cargo log now contain information about the dependencies of add1 and ran. However, even though ran is used somewhere in the workspace, we can't use it in the other crate in the workspace unless we add ran to the cargo.toml file as well. If we add use ran to main for the adder package, then we'll get an error because you haven't add ran as the dependencies in the adder package. Yep. Building the adder package will add ran to the list of dependency for adder. But no additional copies of ran will be downloaded. Ensure every crate in the package using ran package will be using same version. So we won't have two, but it's just that it need to be written down there. Right. Adding a test to a workspace. So add a test for the add one function. in the @1 crate. So we have public @1. So now we have this is the unit test, right? So it's fine. So we can now run the cargo test in the top level, and then we will run tests for all of the crates. So yep, airwork tests in @1 have passed. 0 tests were found in this is the first one running test. So the running unit test for lib RSO is 1. The running unit test for main, which is in the header, but there's no test. Yeah, doc test, no test. So yeah. The last one shows 0 documentation tests. So now we can also run tests for one particular crate in the workspace from top level directory by using the -p tag flag. Specify which package we want to test. So -p @1, so we only run @1. If you publish the crate in workspace crate.io, each crate in the workspace will need to be published separately. Like cargo test, we can publish a particular crate in our workspace by using the -p flag and specify the name of the crate we want to publish. Add 2 crates in a workspace similar way. Ooh, that's additional practice. As your project grows, consider using a workspace. It's easier to understand similar individual components than one big blob of code. Furthermore, keeping the crate in a workspace can make coordination between them much easier. Cool. Yeah, sorry, I'm not going to do this again. I'm just going to quickly read through it because it has been more than 45 minutes and I don't want to spend a lot of times on chapter 14. So installing binaries with crate cargo install. So cargo install command allows you to install and use binary crate locally. This isn't intended to replace system packages. Yeah. Okay. Meant to be convenient way for Rust developer install tool that others have shared on crate.io. Interesting. Note that you can only install packages that have binary targets. Binary target is a runnable program that is created if the crate has a main file as opposed to a library target that isn't runnable. So if you have, for example, built something that is runnable and then people can use cargo install to install it. Interesting. Yeah, I thought that since it's a library, maybe there's other tools that you could build an installer as well. But yeah, I guess you can also use cargo install as an installer, or binary installed with cargo install are stored in the installation roots bin folder if you install Rust using rustup and don't have any custom configurations. This directory will be sitting at your .cargo bin in your home directory. Ensure that they're in your path. Okay. Yeah. Yeah, so there's a Rust implementation of the grep tool called grep. So if you want to install grep, you can use the cargo install grep. Second to the last line of the output shows the location. There's the default location. And the name of the installed library, so it's called RG. As long as the installation directory is in your path, then now you can use RG to run that runs the program to search files. Yay! So yeah, like you can publish applications that's written in Rust on Cargo, on crate.io. So yeah, very cool. Extend Cargo with custom commands. Cargo is designed so you can extend with new sub commands without having to modify Cargo. If a binary in your path is named cargo something, you can run it as if it was a cargo subcommand by running cargo something. Okay. Custom commands like this are also listed when you run cargo -- list, being able to use cargo install to install extensions and run them just like built-in cargo tools. Super convenient. Benefit of cargo design. So you can also add in new commands for cargo, new things, subcommands. So yeah, plug in for cargo. Then you can use subcommands. Sharing code with Cargo and crate.io is part of what makes Rust ecosystem useful for many different tasks. Rust standard library is small and stable, but creates it easy to share, use, and improve on a timeline different of the language. Don't be shy about sharing code. That's what makes it so powerful. Because there's a lot of libraries doing a lot of amazing things. This is same with Python, also for Rust with Cargo as well. Very cool. I think we have go through this this whole chapter 14. Sorry, I am kind of like rushing through it because, again, like I don't want to spend too much time. It's about packaging. I think it's something that we may come back in the future when we have something to publish. Not right now because, yeah, I think right now I just want to like learn how to write some code and do something. But in the future, when we publish something, we can come back to here. Yeah, so that's me. Next time we go to smart pointers. This is very interesting. This is again like also mind-bending, kind of crazy things that is, yeah. And also concurrency. These are very interesting topic of object-oriented programming feature of Rust. Like, yeah, these we're going to interesting categories soon, so I'm looking forward to that. I think that's it for me for today. Sorry, it's been a bit short. Still recovering from all the travel and being very tired, and I have lots of plans for today as well. Yeah, so that's it for me. I'll see you again tomorrow. Hopefully we would do a little bit more tomorrow when we have time. I'm traveling again on Saturday, so try to get as much done as possible within these few days. So I don't know whether we can finish the book before I travel again. If it does, that would be great. Then we can come back to do some exercise, refresh our memory when I'm back. This time it will be 2 weeks of traveling, so it'll be a while. So yeah, but I really hope that like we can finish reading the book, and then so we can come back to the exercises. And then we can do more fun stuff, more fun exercise things to do. So that's it from me. Thank you so much for watching, whether now or in the future. I will see you tomorrow.